Hey everybody, it's Saturday morning again. Welcome back to another episode of the Litecoin Underground. I guess we'll call them live streams, podcasts, whatever. Today we're going to have in Eric Voskuil. He actually was one of the first people we interviewed on Litecoin Underground, I think, going almost maybe 2.5 years ago, something like that, maybe even close to 3. So, he's the author of, you just read it, what is it, Crypto Economics? Is that what it's called, right?
Crypto economics, yeah.
Which is what would you call it, Eric? Like a grand thesis on Bitcoin or
It's a bunch of blog posts that I not even a blog. It's on our dev repo, but just a bunch of posts about different ideas that eventually I just bound together and made a book.
yeah, it's a little more of a kind of an economics, maybe economic principles applied to
Right.
Bitcoin.
It's less about any kind of Bitcoin, explanation, technicals or anything. It's more about conceptual Bitcoin and economics.
Okay. And your history is, I think you explained it last time you were here, but you have like a brief, kind of what you're up to today.
Yeah, in terms of Bitcoin, I'm doing a lot less of some of the things I used to do, traveling, speaking, writing, conference, those things I like. We just passed 4 years since I did crypto econ. That was just kind of hard to believe because we did it on leap year. So it's actually, you could say it was the first anniversary and people wanted me to do another one. But what I am doing is I'm focusing on code because otherwise it's just never going to get done. So I just stopped doing a lot of those things. And in terms of my Bitcoin work, I'm just writing code most of the time, most every day, practically full time, along with working on my house and other stuff. But working on Bitcoin, libbitcoin, and the primarily right now the node implementation. Version 3 has been released for something like 7 years. We haven't really made any major changes to it over that period. Still available, still supported in version 3, but it's not even headers first. The synchronization is so old, but it still runs, and there's a client side stack and a server side stack, and those are actually very mature. So did a lot of work. I basically redesigned, re-architected the node using all the same principles, but getting the architecture finally right after years of prototyping and trying to figure out ways to make it work the way we wanted. I think we finally have it right. So we're starting, people are starting to notice. That's what I work on.
Well, so libbitcoin is, I mean, what would you describe it as? A non-profit alternative option for engaging with the Bitcoin network? I mean, I don't.
The Bitcoin is a developer toolkit. It's a software developer toolkit written in C++, pure C++, for people to write Bitcoin code, and it's the core. It's what we used to call core development before Bitcoin Core took the brand of core. So now it's confusing, right? Anything that used to before Bitcoin D or Satoshi's implementation got rebranded to Bitcoin Core, it used to be straightforward to say you're a core developer, which did not mean you necessarily worked on Bitcoin D, right? It meant you worked on a node or code that was tied to the essence of Bitcoin, right? So by way of analogy, if you're at all technical, you probably know what a router is because you've got one in your house, right? Everybody's got a router, at least a Wi-Fi router or something. And well, in Bitcoin sense, the analogy is a node to Bitcoin is like a router to the internet. There's no internet without routers. There's networks, but they're not connected to each other, so there's no internet. So routers are what make the internet. And nodes are what make Bitcoin. There's no Bitcoin without a node. So core development, central development in Bitcoin is working on node software. And so libbitcoin is a developer toolkit, which means the software developers who want to work in Bitcoin, not something that connects to Bitcoin, but something that is Bitcoin, then they can use libbitcoin to build on top of. And so in order to make, whenever you provide a developer library toolkit, it's one thing I learned at Microsoft, which, that's kind of what they do, is you have to have a customer while you're developing the tool, the tools. If nobody's using the tools are worthless when they ship. And so we have a node and actually the node is an intermediate step. Really, we have a server. We have a client, which is a command line set of tools called Bitcoin Explorer, and we have a server called Bitcoin Server. So we call that BX and BS. Bitcoin node is just a lower level of the server without the 0MQ interface on it, without a way to really talk back and forth to it to make queries against it. So the node is a library, and then the server is another library that sits on top of that. And below the node, we have other libraries like network, database, system that we use to build the node, and then server sits on top of that, plus protocol, which adds the 0MQ protocol, and that's the server stack. And on the client side, there's the Bitcoin system, client, protocol, and Bitcoin Explorer. So
I'm lost.
Yeah, it's all these different libraries that we assemble, right? Like components to make to a client side. You think of the client side as kind of like wallet, but it's not wallet. It's a bunch of tools. You run at the command line, sign a generate key or sign a transaction or something like that, right? Query something from.
So like take for example, Cake Wallet. Obviously they sponsor the show. So what you're saying is when I go into Cake Wallet and now I'm using their node, but they're applying various tools. These tools you're talking about, they apply so that I can interface with them as a customer.
Somebody wrote, I don't know anything about Cake Wallet, but so I assume they're great. But somebody wrote,
very good, yeah.
Somebody had to write the software, right? Okay. Which means I don't know. You said they have a node. They're probably not writing their own node because I would probably know about it. But you're using some node or they're not. I don't know, but somebody has to write all that software, right? So it would be like, if there's not a library like libbitcoin, it would be like saying, well, we're gonna make a car. Like DeLorean went out and made cars, right? Mm-hmm. He didn't start by growing rubber trees to make tires, right? Yeah. He bought the tires from somebody, and he bought the engine from somebody, and he bought pretty much everything from somebody else. Maybe the sheet metal, he didn't make the sheet metal either, but he made the car, put it all together. And so libbitcoin is all that stuff that you need to make something like Cake Wallet, right? Which I'm sure they didn't write. They didn't write a curve library like libsecp. So they might have written some. They didn't write others, right? They didn't write probably the hashing primitives and all that stuff. So libbitcoin, for example, one of the things we don't write, we don't reinvent, as they say, is the curve implementation. We use libsecp 256k1, which is written in C and is widely used and tested. And it's kind of an independent library. We use that. And we use a library called Boost, which is just C++ tools that make things easier. And we use C++. And for the node, that's it, right? Everything else is written from the ground up. So if you want to do hashing of something, for example, we have all the hash libraries. They're written from the specifications up, right? So we didn't use anything else to implement those. If you want to do key derivations, for example, you might do that in your wallet, but writing the low-level code to actually implement that is a lot of extra work that, when you're building an application, you really don't want to have to do, just like you don't want to have to, invent a radio to put in your car that you've just manufactured. You get it from somewhere else.
So you guys are doing because there's a Bitcoin development kit, right? Which I guess is similar in its
not. If you're talking about what I think you're talking about, it's not similar. It conceptually may be similar, but it's very limited. There's no node capability, no network capability, as far as I know. Nothing. It's just maybe some signing and wallet-like stuff. More like our Bitcoin Explorer, but even less than that. So libbitcoin is huge. It started in 2011, and it's last I checked, which was years ago, it was 500,000 lines of code. It's a very large library. I've seen there's a lot of Bitcoin kind of tools libraries. They come and go, but nothing of the scope that we have, nothing that implements a full node. So what I was saying earlier is that the node takes the entire server stack, or the server takes the entire server stack, and makes sure that it's useful to other people, right? And the client, so the Explorer tools, they expose the entire set of like programming libraries as something a person can use. So a very simple user interface. Both of them are command line user interfaces, but they, by being used, right, they guarantee that they ensure that the functionality below them is actually being designed properly and is useful. So one of the things we want to make sure is that our network stack, our node stack, our database, everything is useful and performant and of high quality. So by running a node and targeting certain things like sync performance, validation performance, query performance, performance is a central aspect of node software, critical aspect. And if we don't get that right, if we're not better than everything else out there, then there's still a reason to use it. It's a developer library, which there really aren't any ones of those for this kind of stuff. But you don't want to sacrifice performance, certainly, to do that. So we build these tools like a command line based node, so that people can build competitive products on top of them. And the reason for that is if you're not building directly on a node, you're not using Bitcoin. If somebody else is using Bitcoin, and you may be, you may have an account with them, but you're not using Bitcoin. So if you use a server-based, kind of web API or something to implement your wallet, you connect to somebody else's node. You don't have a say in consensus, and you don't actually have any Bitcoin. You can't prove that you did.
Is the goal kind of like for an average user long term? Is the thought that like, it'd be really great if an average user can have something on their phone where they're connecting to their own node at home and have all these,
or have the node on their phone. There's no reason somebody couldn't have a node on their phone. That's how absurdly bad the software's become. People don't even think that's possible. It's not possible now, but it's not that far off. Okay. And that's just Moore's law catching up. And the reason it's catching up is because, for the first few years, Bitcoin blocks were absolutely empty. So it seemed really fast. The software wasn't fast. When the blocks started getting full, software started dramatically getting slower, but it's doing so at a constant rate. Moore's law is exponential, so it will catch up. And I can demonstrate that, but the software that people use, Bitcoin, you can't. So people can't imagine the idea of like, I imagined, and I know at some point in the future that Bitcoin, the way the consensus that exists today, will be able to run on a tiny little device, the head of a pin, and sync the chain in a second. Even the bigger chain that's that will exist at that point in the future. Okay. But I guess I'm different. I've been around. I started coding on a 16K machine that had not even a floppy drive, like cassette tape, right? And seeing many orders of magnitude performance improvement come since that time in the early 80s. I can see it continuing to happen. I've been working on Bitcoin for 10 years. I've seen it happen already in I use the same computer for the last 7 years. The chain is orders of magnitude larger than it used to be, and it syncs much faster on the same machine because my network speed is faster. So anyway, point is that if people, yes, I do imagine people using their own nodes, but if they're not using their own nodes, they're not actually what we call users, right? I don't like the term user, but you're not using Bitcoin if you don't have a node. You're not on the internet if you don't have a router, right? Somebody else is using Bitcoin, and you're interacting with them, right?
Right. And like when with Cake Wallet, we're using Cake Wallet's Electrum servers. We're not running our own node, right? Despite the fact that we're with MWeb, we're using their node.
Server is a node,
but we are securely. You still own your own keys, type of thing. It's not like you're not asking permission at that point.
Verify your money. Yeah. Owning your keys doesn't matter if you can't verify that it's money that you're receiving. So you sell your car for Bitcoin, you receive the Bitcoin, you gave up the car, you have your own keys, but you didn't receive Bitcoin, you just received some nonsense, right? So if you don't know, you don't know. Now, Electrum's an SPV wallet, right? It has a certain security guarantee. Somebody's running that Electrum node, and you have a limited amount of trust in that Electrum node, right? And by running an SPV wallet, right? But you're still placing trust in that node. If you want to be trustless, you have to be the one running the node. You have to know that the node is
because they could game the node. Essentially, is what you're saying.
They can see your IP.
Yeah, what's the?
Not
I guess
not a question.
What's the concern?
Not a question of privacy. There are limits to the to SPV, right? There are known weaknesses in SPV. It's pretty good. It's better than a trusted wallet for absolutely sure. And I've used Electrum many times, and I expect libbitcoin will be an Electrum server. But you have a much higher security guarantee if you are running and control the node that serves up SPV, right? Otherwise, why would anybody run a node, right? Why would there just be one Electrum SPV server and everybody just trusts it? That is not a secure system. Right?
Like for instance, I've been on Cake sometimes, and they're having issues. Like if their node isn't syncing properly, like it's for whatever reason, you'll have where you have to, like, there's a couple nodes you can choose from. You have to just change the node you're referring to. But like if their nodes went offline, I still have my seed words. I could take
that. It's not about your keys. That's not the issue. It's
what I'm saying. I wouldn't lose my money, but I may have access difficulty.
Well, we're talking about two different things. People seem to think they've got their keys, so they've got Bitcoin. No, you've got your keys. You got the ability to spend whatever kind of money you have, which may or may not be Bitcoin. That's all you have, right? To have Bitcoin, you have to have validated that you received Bitcoin onto the address that those keys can sign for. So let's take it to the logical conclusion that might exist if everybody just did SPV, right? If nobody runs a node except one person and provides everybody else an Electrum connection to that node, right? Everybody's using SPV. That one person gets to determine what the money is. So in other words, they can introduce inflation. They can do whatever they want, right? Because the people receiving the money through SPV are not validating the blocks. They're trusting that somebody somewhere is validating the blocks.
So the nodes,
that strong chain, that strong header chain, right? Eventually, and therefore they'll know that there's a deviation, but somebody has to validate the chain, right? And the idea that everybody uses SPV kind of assumes that there's a bunch of SPV servers out there that are kind of competing, and some of them are going to be honest. But that's an assumption. If you want to know for sure, you validate. You don't have to trust that anybody else is, or that everybody else is honest, or that that not everybody's dishonest. So
being honest is following the longest chain.
Sorry, the longest valid chain.
Yeah. Right. Okay.
How do you know it's valid? You didn't validate it. All right.
Well, because when you mentioned the routers as like that they make up the network, right? That's like the internet. You can have information sitting on a server, but if nobody's connected to it and nobody can communicate with it, then it is not the internet. It's just a bank of information somewhere.
If you have a network in your house, that's a LAN. It's a local area network. It's not the internet.
But what I'm saying is that, like,
you connect two of them together, now you have a wide area network, the internet. Right?
But like Bitcoin itself is the interconnectivity. Like without it, you don't really have anything worth anything.
Well, it's not the P2P network. That's not Bitcoin. You could use carrier pigeons to fucking deliver transactions and blocks. That doesn't make it not Bitcoin. What makes it Bitcoin is validating the chain, and the validation of the chain. I mean, so it's not the same as a router. A router is about communication and passing around public routing tables, and trust became an issue eventually in those routing tables. But routers relay to each other routing tables, public information. Bitcoin P2P network relays to each other nodes blocks, which is public information, and stores it and validates it and uses it to tell you whether or not you've got money. But the transport protocol doesn't have to be P2P network. And just like in the internet, it doesn't have to be IP. It just happens to be, right? So if you don't have a router, if you don't have a way to communicate with that other network, you're not on the internet. And if you don't have a node, you don't have a way to know if you have money or not. So you're not using Bitcoin. You have placed a certain amount of trust in the network, even with SPV, which is a very strong security guarantee under certain assumptions. And if those assumptions are taken to the extreme, in other words, when I say extreme, like if we go like generations, like I go 100 years and nobody uses anything but SPV, but that means nobody's running the nodes that are providing the SPV. Everybody's just using SPV. But that can't be true. Somebody has to be running a node to provide the SPV to the SPV queries, right? So who's running that node? Well, that one person maybe running that node is the authority. They control what the money is. So
what you're saying is if everyone like uses, I guess, hijacked SPV nodes, it's possible that you can send a transaction to someone and the recipient might actually get it, despite the fact that it's not written to the chain.
Well, yeah. If you're on a Sybil network, right, where you don't have control, every connection you're seeing is a bogus SPV server, then yeah, you can fall under attack. And people say, well, the same is true with Bitcoin. If you deny somebody access to the P2P network, if they Sybil your Bitcoin network, you're going to see you're not going to see the strong chain, but you will see a valid chain, right? You're not going to accept an invalid chain. So the only way you're going to see a weak chain, right, is if somebody's mining a weak but valid chain, and there might be a stronger chain out there. There's always a possibility in Bitcoin there's a stronger chain, and you have to be able to see that. But the difference between that and SPV is if you're Sybiled, you can be seeing an invalid chain, right? And it can look as strong as a strong chain. It still requires work, right? Just like in the Bitcoin scenario, which is why it's a fairly strong guarantee. But it does require that you trust that what you're seeing is valid. You don't have, you're clearly not validating, right? So somebody else is telling you this is valid. Now you're validating the headers, so you know that the headers are valid and they contain sufficient work along the requirements of the current path, but you haven't validated the transactions, and you can't without the full chain. So if somebody's Sybiled the entire world, right, there's no way for anybody to know or prove different, right? You've got to run your own node. So to me, it's not as much that today it's an individual person's high security risk, right? The problem is that it's kind of like pruning or kind of this assume UTXO or these things that basically if everybody did them, there'd be no more Bitcoin, right? Somebody has to actually validate and maintain the chain. If everybody prunes, then who can bootstrap and validate the chain? Nobody. So somebody has to do it. Well, if there's only one person doing it, then how do millions of people sync with that one person, right? So these things can be deleterious to the network if everybody does them. And I don't really like the idea of building a system that works, that runs faster if everybody does the wrong thing, or looking at it the other way, that breaks if everybody does the thing you want them to do, right? If everybody there's no more Bitcoin.
Is like the centralization of mining pool, like the fact that the mining pools are becoming fewer and fewer, does that further make this possible to exploit because it only requires the coordination of a few entities essentially?
Well, centralized mining is certainly a risk on a more than that level, but I'm not sure that it's getting fewer and fewer. I mean, we've had a fairly centralized mining for a very long time.
Right.
I mean, we've confirmed, at least we believe 51% going back like 8 years. So in the hands of one miner. So whether that's the case now is open to debate. But okay, so I don't necessarily think that it's changing. But
would it be obvious? I mean, it would be pretty obvious if suddenly another chain was being mined heavily. Maybe what you're saying is the bigger concern is like, I guess I'm trying to understand if a longer chain starts to get mined by a small portion of people, and the SPVs are referencing that longer chain, even if it's not considered the popular chain.
Let's just say that 51% controls mining, and they decide to execute what we call a 51% attack. I don't call that a 51% attack because they're not doing it to necessarily reverse transactions and steal, your car that you sold them for Bitcoin. That's the attack. It's more of enforced censorship. So this is exactly what happens when we deploy a soft fork with mining enforcement, which the only thing that makes it compatible, right? Majority hash power enforces a rule change. Okay, everybody gets the rule. So hash power can do that. That's the way it's designed. They can reject otherwise valid transactions, and that's what a soft fork is. So that can happen, right? And what could also happen is if that one miner decides that they just want to, I don't know, create an inflation rule, hard fork, right? If you're not validating, how do you know? So they might not be a second branch, right? They may be the only branch, or there may be a second branch that's being suppressed by the majority hash rate. But what if the strong chain is actually not a valid chain? How do you know?
Okay.
Because somebody has a node, somebody else is doing it for you, right?
Right.
And so if there is nobody else, then what happens? So everybody can't run SPV, right? And you can't trust the one person who does. They can't prove to you that they haven't introduced a hard fork. You have to prove it to yourself. So nodes are critical. They're essential. And you won't find any core developer that doesn't understand the essential criticality of nodes to the survival of Bitcoin. So here's what's really been happening over the past years that I've been working this problem, which 10 years I've been working on, actually coming on 11 years I've been working on libbitcoin. And for like 7 years or more, I've been working on this one release. So basically, I mean, my time has come and gone, but it's been, maybe 5 years full time, at least, working on prototyping and, redoing and trying to figure out how to solve various problems, because what we're seeing, and now it's starting the chickens are coming home to roost. It's getting so slow to run a full node that it's becoming impossible. I mean, I wouldn't say it's impossible, but I'll tell you what, I'm sitting here, on a machine with 256 gigabytes of RAM, 32 dual core, 64 threads, right? Slower, they're 2.1 gigahertz threads. This is a 7-year-old machine. PCIe 3, so not bad, with a, super fast SSD, as fast as PCIe 3 will take, and some, and that memory is PCIe 3 too. Anyway, so 7 years ago, this was a $12,000 computer. And this thing, when I fired up Bitcoin Core on it recently, how long do you think it would take me to sync the full chain off the internet? Oh, by the way, my network is 2.3 gigabits per second measured download rate.
I don't know.
I've heard it's a couple days, right?
Yeah, it's on this machine, on that network. It's I haven't finished it yet, but it's at least 15 hours. It's probably going to come out longer. So this isn't my test bench machine, but I decided to try it out anyway. I have test machines that are more standardized. 14 hours on one of those machines, which is on a 2.3 gigabits per second network, right?
And probably a machine that the vast majority of people
without even validating.
Yeah.
Sorry, I'm giving you numbers without even validating the chain. Just to get the blocks down. 14 hours on a pretty high-end machine, right? If I validate on that machine, it might not even be any slower, because it's so slow that it'd be plenty of time to do all the validating, but I don't know. So I've gotten it to the point where I can do all of that on that $350 machine in 1 hour. Actually, 47 minutes I'm down to now.
So can I ask,
how do you do that?
This was a big deal.
Not that much data. It's theoretical limit on that data for transfer is 38 minutes on my network. I should be able to do it in 38 minutes, right? The reason it takes longer is because there's some overhead, right? But I'm still chiseling, chipping away at that, trying to get it down to the theoretical limit, and trying to make sure that when I get a 10 gigabits per second network or 100 gigabits per second network, it goes that much faster. So 10 gigabit per second networks are being rolled out in the United States right now, right? They're kind of early, but I can remember I started working on this. I think 10 megabits per second was the best I could get, 1,000 times slower, right? Now, so we're going to have networks that are now 4 to 5 times faster than what I'm seeing on mine, and I do this in the theoretical limit 38 minutes. I can do it in 47 minutes. So that means I can get it down to 10 minutes. Okay, that's what it should be. But it doesn't matter how fast my network is right now. With the Bitcoin D architecture, it makes no difference how fast my network is.
Well,
I could have a terabit network and it wouldn't go any faster.
Yeah, well, I'm curious because this was obviously a big thing. I first got into crypto in 16, 17 era, and so I was pretty much a noob. And a lot of this stuff, I'm still a noob in learning how, like, the importance of the node, right? And that was the big debate between the block size wars, right? Like, if the blocks get too big, your average person isn't gonna be able to run a node,
right?
And we kept the blocks small, and ironically, yeah,
it's not because the blocks are too big; it's because the software is too slow.
Gotcha.
Mm-hmm.
That's
the size of the block really doesn't. I mean, is there a point at which
the block does matter? It does matter, right? Okay. If there was no size limit on the blocks, what would happen is there would effectively be a limit anyway, because you have to mine the blocks. It takes forever, practically forever, to compute the optimal set of transactions to go into a block, because new blocks are coming, new transactions are coming, things are always changing. The computation is NP hard. It's just, you just kind of have to guess, right? Use a knapsack solver, and that's how we guess. That's to fit them into 1 meg plus SegWit, right? But if you have no limit, well, you have to guess, right? Like, what's my limit? Because I need to start mining eventually. I can't just be computing new blocks all the time. I need to mine. So miners would effectively have to put an upper limit on how much they could try to get into a block in order to have time. You have to balance the time mining versus the time computing, right? To generate the block template. So there would effectively be a limit anyway, but that limit would be imposed on based on miner capability and successfulness versus non-miners, right? People that are what I call merchants, people that are using the node to validate transactions. So if you went to the limit of what miners could mine in terms of block size, you're probably going to be in the point where merchants can't merchant, right? That's my theory, right? That's why there's a block limit, because it imposes with blocks being basically on a 10-minute period, it imposes a linear growth that's within what we consider reasonable for people to be able to sync, right? Now, SegWit made the blocks 4 times bigger. Mm-hmm. So, I was working on this before SegWit, and then all of a sudden SegWit comes along and goes, well, okay, now that's, in terms of Moore's law, that's a couple, that's doubling every year and a half. So, okay, that set us back a few years, but we'll still be able to catch up, right? And people, now you can see that's having an effect, right? That SegWit block size increase is having a material effect on the ability of people to sync. Mm-hmm. But it's not the cause, because the growth, which is bounded per 10 minutes, it's got a linear upper bound, right? It's a linear growth, whereas hardware performance for the cost, the dollar cost, grows exponentially, right? The cost drops down to so you get this performance curve, which is going like this, and you get this linear curve like this, and then
right,
it'll become zero. It'll become effectively zero cost at some point, unless you increase the block size, and you keep doing that. If you keep increasing the block size as Moore's law increases, you'll prevent it from ever catching up, right? You could. So that's one of the hazards. If you made blocks smaller, it would get there faster, but it's going to get there anyway, and it's already there, right? For reasonably cost hardware. Like so what happened is, recently I told people, hey, I can sync the chain without full validation, right? This is just what most people do. They get Bitcoin Core, they synchronize it using what's called assume valid. So basically there's a mark on a fairly high block that says, okay, we're telling you this one's valid, so you don't have to validate all those, and then you start validating after. So if you do that, and Bitcoin Core on this machine, 14 hours, this $350 machine I bought on my fast network, I did the equivalent thing with libbitcoin takes 47 minutes. Okay, that's just a software implementation difference. It has nothing to do with the block sizes and has nothing to do with the hardware. That's a software implementation difference. Now, there's consequences of that. Other things may be faster or slower, and in many cases in Bitcoin, they're also much faster. So we're just working through, like, the validation phase itself is different, and you need to be able to validate. You can't just do this assume valid thing, right? So we work on that as well. And I just did last night, I ran on my bigger box, I ran a 6-hour download and full validation on my big box. Well, on that big box, just doing the download portion is going to take at least 15 to 20 hours with Bitcoin Core, just without validating at all.
So when you say assume valid, like, how far back is that the same as kind of pruning in a way? Because you're essentially trusting from a certain point.
Pruning the validation. It's not pruning the data.
Right. That's what I meant. Yeah.
So it's just sort of like a checkpoint. Checkpoints don't exist for the purpose of skipping validation. Checkpoints have that effect, but they exist to make sure that try to make it easier to avoid syncing weak header chains when you're getting started. And
how far back does that assume valid generally go? Is like a year? Or
assume valid goes forward towards the tip of the chain, and it goes everything built before that. So currently, it's somewhere around it's somewhere above 850,000. It's very close to the top, right? So basically, when you get downloaded and run Bitcoin Core, they kind of update this for every release, I think. And so you don't validate. Now they do like, this is kind of silly. They do partial validation. They just skip like the script and signature checks. There's no point in doing any of that partial validation if you're skipping the signature checks. You should be skipping all of it, but their architecture doesn't really allow that. Or at least they haven't done it. So it's just wasted work, right? If you're skipping any part of the validation, there's no point in doing any other part. It's not more secure than the assumption of the block in the first place. So you basically, all you need to do is download and index properly this data with that assume valid there, and still it can take days, if not weeks, on some people's networks and machines just to do that. The validation is necessary for the network, security of the network anyway.
So I'm probably being dumb. I'm pretty dumb with this stuff, right? So when I'm validating, what I'm looking at is saying, this person sent me a transaction. I'm looking at kind of the history. Do they actually have the coins, right? That's what I'm validating. Like, what am I checking against? I guess if I'm running a node, what's my reference point? Another node?
No, the rules, the consensus rules.
Right. Where are those coming from? Like the most recent.
When you download the chain, yeah, it's from other nodes.
No, the rules are coming from the software. So libbitcoin or Bitcoin Core implements the rules, and one of the problems with this is a kind of a tangential but important issue. Is one of the problems is people can't understand the rules, and Bitcoin. Bitcoin Core type people will tell you that the software is the rules. Well, there's hundreds of thousands of lines of software. The rules are not all of the software. The rules are isolated aspects of the software. And one of the things that we spent a lot of time doing in the Bitcoin is isolate the rules from the software so that they're readable by somebody with kind of basic level of competence in programming.
Okay.
I, who've been working in this stuff for a decade, when I go into Bitcoin Core to kind of tease out different aspects of consensus rules, it's a very tedious process, even for somebody with familiarity in the code, and nobody would disagree with that. It's very hard to see what the rules really are because the way they're written. So So when you ask, like, what am I referencing this against? You're referencing it against rules which you don't understand and you can't read in the code, right? And the aspect of what should I say? It's not in the chain. It's in the code. And if you don't validate, you're not ensuring that the code that the chain is valid. And if you don't understand the rules, it's really kind of pointless anyway. So
Well, because I have a very, very limited technical background. When I hear, I always think there's software and there's hardware, right? So software is engaging with hardware somewhere
Yeah.
along the line, right? So
Yeah.
in my mind, that software, when you talk about a reference point, it must be touching base with the hardware. Is the mining the hardware?
So what are we're talking about receiving money, right? Receiving coin, and somebody sends you some coin. You're asking like, how do I know I've got money?
Yeah, you mentioned validating the chain, validating transactions.
Validating the
What
chain.
am I? So I think of validating. I'm going, okay, this says this, this says this. They're the same, right?
It's not. It's a logical process. It has nothing. It's not essentially tied to software or hardware, right? It's math. It's a mathematical process that you're going through. Yeah,
Okay.
You need two things. You need a pencil and paper, and you need the data that purports to be the chain, and that data is just public data. And when somebody sends you a transaction, it's a money, you're validating that transaction against you're validating the public data, essentially the transaction has become part of that. If it's not mined, it's not anything. So that transaction is in a block. You found the public chain that contains the transaction, but you want to know, is this what everybody else is going to consider money, so that when I go to spend it, somebody will take it? Or is it a fake chain that this guy who just paid me sent me, right?
Okay.
Or is it a bigger issue of, he thinks it's legit and everybody else thinks it's legit, but somebody has subverted the entire process, right, by introducing rules that we don't know about? Well, how could they possibly do that if you got your pencil and paper and you're validating all the rules? Well, the only way they can do that is if you don't validate all the rules, right? So you have to know what they are, or or you're putting your trust into somebody else who does.
So something basic like 21 million cap, right? That's a basic rule. Like there's no inflation.
Okay, yeah. So Bitcoin Core,
we can all understand. Yeah.
Bitcoin Core introduced a bug in 2019 that effectively removed the 21 million cap, right? It's called the inflation bug. It was introduced, shipped, and people deployed it in mass, right? And then it was found out, and they announced it, and there was a lot of updating software that happened. So it wasn't exploited. Nobody mined any blocks, as far as I know, that took advantage of it. But how would anybody know if somebody did that, if nobody was validating, and somebody did it intentionally on their one node that everybody trusts and uses SPV against? How would they know? When you went to validate, all you would be validating is that this transaction, say SPV, and this transaction is attached to this header chain. The guy sent it to me. The header chain, I've verified. It's got proper proof of work and everything. And this transaction properly attaches to that chain. And you can't validate the transaction because you don't have the previous outputs, right? You can go get those. But in order to know that the previous outputs, which is in other words, the money that the other person had that they just sent to you, how do you know that that's legitimate money? You have to go all the way back to the origin of that money, which is the Coinbase, right? And that can propagate through the entire chain. And then you have to make sure that there hasn't been more money introduced in a given block than should exist, or that money that he sent you wouldn't be real. So the only way you can answer these questions is by validating the entire chain. So if the only person that you can reach, is introduced that inflation bug, and nobody knows about it, and somebody's exploiting it, you don't have any way to know, right? So the thing that prevents that ensures that the rules are complied with are individuals validating their money when they receive it. It doesn't matter if you run a node that sits up on AWS and just validates if you're not receiving money, right? That doesn't do anything for the security of the network or the consensus rules. You have to actually be taking in some payment for some goods you give back. And when you receive that payment, you validate, you say, oh, that's not real money. The person doesn't get the goods. That's what stops them from spending the money, right? Validating in a closet somewhere and not receiving anything stops nobody, right? It's only the people that are receiving the money that have the ability to stop the bad money, the non-money, from getting spent. So
So
people have to
non-economic
validate,
nodes.
and they
We
have
call
to
it like
validate
non-economic
as
nodes, right?
merchants. Yeah, non-economic nodes don't
Yeah.
count. So the nodes are essential, right? And if node is the software that does what you'd be doing with your pencil and paper mathematically, and of course the software resides on some hardware, and they work together to produce this outcome. The software could all be implemented in hardware and it'll be the same, or you could have some simple Turing machine and you do the whole thing in software. So that's not really the critical distinction. The critical distinction is that so I started to say this before and I got a little bit off track, but what's happening right now is that the performance degradation of the network is accelerating, right? And people are kind of freaking out about that, and that's why you've got Luke and all the filter boys out there screaming about spam killing the network. Well, spam's not killing the networks. Bad software is killing the network, or slow software. I didn't say it's bad software, but slow software is killing the network, unoptimal software. And so what's happening is because I think in part because the software is so complex and so fragile, the implementation, Satoshi's implementation, people, you probably understand this. It's hard for people to get significant changes into the software. So it doesn't evolve very rapidly, if at all.
Right.
And new stuff, can kind of get added on, but changing the older stuff is really hard. So the architecture doesn't change. So what's happening is in order to solve, people have been told that this is the most performant, best tested, most reliable software that's ever been produced, which is absolute nonsense. And now with a kind of a new guard in Bitcoin Core, they've started to be more open about bugs and issues and stuff like that, which is great. But the truth is, it's just like any other software. It's got bugs and it's got design issues and whatnot. So there's this hesitancy to make significant changes. There's this realization that it's getting harder and harder to sync the chain, but there's this cognitive dissonance that's been introduced because people believe it's fully optimal, right? So the only way we can solve this problem is, Luke says, make the blocks smaller, stop the non-financial transactions, which he calls spam, right? And we'll donate our, mining losses to trying to make that happen, which is great. He's on a crusade to solve that problem, but it's not an actual problem. Right. The problem is the software is not performant. and so that's one approach, is to just reduce the amount of data going into the software. But even if you reduce it at a constant rate, we have an exponential problem. So it's not gonna really solve the problem. Right. Mm-hmm. And then on the other hand, you've got more of the kind of Bitcoin Core type community. I'm not really kind of part of that club. I communicate with them, but what I see coming out of that is all these interesting techniques, right, that are kind of highly technical, cryptographically related, right, to try to prove the chain so that you don't have to download the data, because it's not going to be possible to make it performant. So for example, assume valid was one of these things. Let's just not validate anymore, right? We'll just let the developers tell you this is valid, then you can download. But the problem, the download's slow. The download's actually so slow that the validation doesn't actually make the lack of signature validation in some cases won't make any difference at all. Not on my 64 core machine.
Or a minor enough difference, it would be pretty imperceptible.
Right. I think it actually on my machine, it's possible it won't make any difference at all. Because I got 64 cores and it's downloading so slow, the cores are just sitting there idle, right? It wouldn't make any difference if you have to hit the CPU limit before dropping signature validation actually helps. Right. So anyway, so there's assume UTXO, right? Assume valid, which we don't call it that. We call it a milestone because we don't want to make any assumptions. If you're using this feature, it implies that you downloaded and validated in the past. You wrote down the hash of this block, and you're going to remember that. So next time you don't have to do it again. So you're not assuming. Yep. You're just relaying your own trust. And you put it in as a milestone. I've seen this fork on the road before. I've seen this point on the road before. I know it's valid. So if I see that again, I'm not going to validate all those blocks again. Okay, right. Fine. Checkpoint's different. Checkpoints are part of the consensus. You don't have to validate anything before them, but they're now so low. We get past the top checkpoint in a few seconds. That's how fast we are. 295,000 blocks in just, I don't know, less than a minute. So so you get assume valid, but then you get, well, that's not good enough, right? And again, I've explained it's not, that's not solving the performance problem in a lot of cases. So then you've got SPV as another attempt to solve this problem. That's really all it is. If you could do this performantly, you don't need SPV. You don't want SPV, right? It's a compromise. And then assume UTXO. So libbitcoin doesn't have a UTXO store. Bitcoin Core has a UTXO store. So I don't, I guess not. That's incidental to the point of assume UTXO. But assume UTXO is, we take this UTXO store, which is a subset of the entire store, and it's kind of what we use to maintain what's been spent, what hasn't been spent, and we'll just. I think essentially the idea is you take this blob of data, you sign it, and you make it available for download, right? So somebody can just go to this place, download the set of UTXO data, put it on their machine, and they can start using the node. Right? They run, say, Bitcoin Core, it validates the signature, and they start using the node as it was just a fully synced and pruned node, right? And then in the background,
there's an assumption that all the UTXOs on there are valid.
Assuming that, the entire set, not just the ones that are there, but the ones that are not there, right? That is what determines what's been spent and what's not been spent. So if it's not there, it means it's been spent. If it's there, it means it exists and it's been unspent. It's been validated. All that stuff's assumed.
It's holding valid Bitcoin.
It's basically holding the state of validation in the chain, right? And so it's a much smaller, I don't know, it's like 16 gig or something like that. I'm kind of guessing, but much faster download, you boom, and you can start using the node. But you're fully trusting
right.
the Bitcoin Core or whoever has provided the signature validation for it. So public key, right? So look at what's happening in each of these situations. We're making a security compromise that if we, sometimes on the individual basis, like assume valid, assume UTXO, those are individual compromises. If I accept that, I'm making the assumption and it's my money at stake. But then there's the bigger picture ones where if everybody, pruning's another example. Pruning is less focused on initial block download. It's more focused on disk space, right? Which is the cheapest resource that you could have on a machine. So it's, to me, not a great idea because you can't bootstrap new nodes. So if everybody prunes, there's no more Bitcoin. Nobody can validate. Nobody can even synchronize. So pruning, SPV, assume valid, assume UTXO, all of these things are trying to solve the same problem. It's too slow to get a node running, right?
But so why is it so long to download the chain, and how does libbitcoin do it so much better?
What are the trade-offs, right? Yeah.
The chain is about presently the BTC chain up to, say, block. I use a fixed benchmark for like a year. So 800, I just moved it up from 840,000, which was the halving, to 850,000 because it gives me nice even 50K chunks for graphing and stuff. And it's now like the real chain is like, I don't know, 860, 70, 80, something like that. So it's pretty close to the top. And I measure up to that. And up to 850,000 blocks is around, it's close to 600 gig over the wire, which means if you use the wire serialization of the blocks and you only transfer blocks and there's no other communication, you just download it as one big blob, it's like, I don't know, 560 gig or something like that. And then, your storage efficiency can vary. libbitcoin is more compact than Core and has a feature where if you're on a big machine, it can be even 50 gig, even more compact than that. It just takes more processing. That's not really, to me, very consequential, the store size, because how much does it cost for a terabyte now? A few bucks, right? So it's not really that important. It would be like complaining about a kilobyte, which we used to do in crazy when I started out. Kilobyte, the whole machine can only hold 16. Right? So we're talking about approaching terabytes of data. It's about 0.6, right now, 0.5 to 0.6 terabytes of data coming over the network, which if you do the math on a 2.3 gigabits per second connection, comes out at 850K, comes out to 38 minutes to download it if you did nothing else. So that's a lot of time, but okay. In say 2 years, when I got my 10 gigabits per second connection network and the chain has grown by another, say 10, 20%, that will take how long? That'll take it'll be 5 times faster, 4.5, 5 times faster. But then you go, a couple more years out from that, we're at 100 gigabits per second, and terabit networks are coming, right? Mm-hmm. Terabit network, What does that tell you? That's bits, not bytes per second. But say we're up to a terabyte by then of data, right? Or more, and a terabyte of data. That means 8 seconds.
Yeah, it'll
Right.
take you the same time to download the whole thing as it does now to synchronize, right? Like after a couple
It
days.
should take no more time, right? Or marginally no more time, like a few percent, right? To download the entire chain and index it and store it on the machine as it takes to download it as if it was a movie or a single file. And that so a terabyte download in the not too distant future of just a straight download is going to take under 10 seconds on a terabit network. That's what it'll take. And that's real. That's coming. I mean, we used to laugh at the idea of a gigabit network or a megabit network. And all right, yeah, terabit. Mm-hmm. That's coming. And I think I saw recently somebody, had found out how to do, and without changing even the hardware on the wires, right? Without changing the fibers but changing the hardware on each end, but not changing the wires, now way faster than terabit, right?
Right.
So the amount of data will become as inconsequential as, geez, we text each other photos. I remember waiting a day to get a photo. 300 baud network, and that's a low res grainy little thing. Now we're texting each other 4K video clips like they're nothing. So people understand how fast this changes, and I'm just trying to get to catch up with where we're going to be. So the software has to be able to scale to that. And that's why I bought this monster machine 7 years ago to start working, because I wanted to have a better idea of where we're going to be when we get there. I'm not designing for the 8 gig laptop anymore, right? I'm designing for the terabyte of RAM, right? The unlimited free super fast SSD, my at least 128 dual core machine, and a terabit network. That's really the future that I'm looking at. And I said SSD. I really, and we've got this in our kind of conceptual design docs, no disk drive. This is just it's just memory, right? So I've got my Mac here has 758 or 668 gigabytes of RAM. Okay, I can put the entire chain in RAM.
That's insane.
That was the reason I got that much RAM. And so when I got the 7-year-old machine, 256 gigabytes of RAM, it was enough to hold almost the entire chain, if not the entire chain, when I got it. So my objective has always been to be able to. So when you're operating with that much RAM, the SSD is gone. We're memory mapped. In other words, we map on and off the disk. But we're basically just dealing with a giant map of memory. That's it, right? So it's not optimized for hard disks, which move stuff off and off the disk efficiently because they need to. It's optimized for pure memory, and we page it on and off the disk fairly inefficiently, very inefficiently. So our biggest problem is, when you have limited RAM, you got a lot of paging off the SSD, and you could run into what's called thrashing. But even on these cheap $350 machines I bought recently, I can't make it thrash by downloading the chain. It's partly our design. But at some point, we're going to be at the point where you've got a phone that's got a terabyte of what do we call it?
RAM.
Static RAM.
RAM disk.
No, well, I mean, phones don't have disks, right? So they've got memory. That's it. Like where's the disk? There's no sync back and forth between the disk, right? And so it's super expensive to have fast memory that stays active when it's off, right? I forget what
Someone said flash.
No, it's not flash. Anyway, it exists. It's just not as fast, and it's more expensive. But we're going to come to the point where you have a tiny little device that's got terabytes of RAM that stays on without power. Or has permanent power, and you don't have to worry about it, right? And you can sync the chain on a terabit network in a few seconds and validate the whole thing on your, hundreds of cores, and it's not going to matter. Well, it already doesn't really matter that much.
So, I'm kind of curious because, I'm bringing back the block size thing, and obviously because Litecoin's a larger block set, and I've always been of the mindset that, growth, if you've reached this upper bound of transactions and scaling through these other layers isn't proving to be effective yet, which I don't think, like something like Lightning hasn't been proven to be effective, that growing the chain in a, like you mentioned, in a linear way of some sort of maybe we double the block size until we figure out a better way of growing. Do you feel like growing at some point, to your
How
point,
big's what's your block size limit?
So in a
it's still
year,
one. I mean, it's the same as Bitcoin, but it's
But you said it's
four
more.
blocks. There's 4 blocks every 10 minutes instead of.
Oh, okay. The frequency is higher. Yeah.
Yeah.
So you've got 4 times the frequency, probably not as much volume initially, but now you probably have full blocks, right?
no,
Getting
and I think
there.
in a year, the full, like the maximum, say you fill the blocks with spam. In a year, the maximum it can increase is about 840 gigs,
Mhm.
right?
Well,
Yeah.
my question
The
is like,
the 4 gigs every 10 minutes. I did the math on that. Yeah, and it comes out to a couple hundred gigs. And so if you went 4 times faster than that because you got more frequent blocks, then you get up to a pretty rapid rate. So this is a consequence. This is the math is pretty straightforward, right? If you hit the limit, then you see the consequence of increasing the block size, right? That can outpace the ability of the hardware for a time. But if it's fixed, it will still be superseded by Moore's law, right? Even Litecoin being four times bigger, right?
Exactly. Yeah.
well, so you mentioned the merchants at some point would have to, there'd be a bandwidth limit essentially from them, like saying, like when you say BSV, they've got gigabyte blocks. At some point, they're going, the miners themselves will say, I can't spend all my time on transactions. I have to focus on mining, right? Like,
well, they need
would the free market, like a free market principle of, would it emerge at some point? And maybe what we're seeing in competing chains is that a free market will emerge where there might be chains that they go, I don't want to even get involved with BSV because it's too big and it's doomed. And so they don't want to bother. I mean, I don't think we're at that point where people even think in those technical terms yet.
People do comparisons to Visa, right? The transaction volume. Somebody cares and bothers because they do it, right? They do this huge volume.
True.
They're processing them, they're validating them, they're storing them. It's all done centrally, but and it's more efficient because it's done centrally. But somebody will care and they will have that choice. And when we're talking about seeing transactions, that's just peer-to-peer network. That can be anything. That can be a centralized network. That can be carrier pigeons. That can be anything. You could be a website where you post your transactions, which is kind of like what Ethereum seems to be breaking down into, I think. What I read the other day, I don't know. But so how you move the transactions around before they're confirmed is really not consequential. The P2P network has the advantage of being sort of anonymous, but it's really not, because despite efforts of good, best efforts of Bitcoin Core people and others to try to make the postings the propagation anonymous, it's not. You really need an anonymizing network like I2P or Tor, with which you can post your transaction to a public server, and then it doesn't matter, right? It can all be centralized. It doesn't matter. So I'm not really too concerned, about implementing an anonymizer. That's a much bigger, cypherpunk issue than Bitcoin. And Bitcoin should, people should use it if they want anonymity in terms of introducing transactions or blocks to the network, right? You want to mine or transact privately, that's what you need. So
do you mean like mixing in the mempool?
Whatever tech, yeah, that doesn't work.
Okay, good to know.
I'm talking about if I formulate a block and I want to be an anonymous miner because mining is illegal and I'll be executed for mining, right? Because I'm not censoring the way I'm supposed to. Or I send a transaction to somebody and it's illegal to use Bitcoin because I'm in a tightly currency controlled country. I want to post that to the network. How do I do it? Over my IP network, right? My IP address will be known and the transaction will be seen showing up on the network. Now I can have a node running and have all these other transactions come in and slip mine in there, right? And try to get it out to the point where nobody else sees it, but somebody can see the first one, right? My ISP can see it, right? It's really, they tried Dandelion and some other approaches, but these things are, you can't be the origin and be anonymous, right? Whether you're a miner or a transactor. But what you can do is connect to a public node as a miner or somebody transacting using an anonymizer. Nobody knows who introduced it because their IP address is hidden, and it shows up at a public node. So it could have been anybody. Okay, Now you're only trusting the level of security of the anonymizing network. That's a mixer, right? Mixing in the pool doesn't do any good. You sync your pool with somebody, and you're the first person that has introduced this transaction. Doesn't matter who you mixed it with. So you have to have a certain level of trust in your immediate peers in order to believe that you have that privacy. And how do you get that trust if the ISPs aren't even trustworthy? So you need to go back to an anonymizer. And so I would never trust that. It's more obscurity than it is. It's kind of like mixing in, Bitcoin mixing in general hasn't shown itself to be too private. And I think that was understood from the start. It's a best efforts kind of thing. I mean, really all of it, even, Tor and I2P, they're best efforts. But I don't know, we can get a little sidetracked on the privacy.
No, that's all right.
But
yeah, I guess, yeah, I mean, you're talking about in environments where your own government's wanting to limit you.
I'm not, I'm not going to ignore any possible threat, right?
Yeah, no, it's fair.
The state is the primary threat, right? That is the primary threat, and presumably it's your own state that you care most about, right? So,
right. Yeah.
So you don't.
Other states can't do much to hurt you, right? Yeah.
I don't care what the Venezuelan currency controls are, unless I'm transacting with somebody in Venezuela or I'm in Venezuela, right? And for me, like, Bitcoin's not for me. I have this conversation with people all the time. I don't need Bitcoin. I can't really avoid, or I'm not willing to take the risk in most cases, right? To get the benefits of using Bitcoin. I develop Bitcoin for other people who are in situations where it's worth taking the risk to use it. And right, like in the U.S., you pay tax on your Bitcoin. You pay capital gains tax, right? Anybody spending Bitcoin long enough, it's all capital gains, right? It's not private, and you pay tax, and there's if they pass a law that says illegal, now you're a criminal to use it. Now you got to take the risk, right? So question is, where is it worthwhile to do that? Well, probably Zimbabwe, Venezuela, Myanmar, Russia, Ukraine. There are places in the world where it's China, where it's well worth it to some people, where they have really no other option, and that's why we develop Bitcoin. So, do we care about Visa level transaction capability? That's not my highest priority, right? Is Lightning kind of buying my beer with Bitcoin important? Not really ever been a priority. I've never worked on a layer 2 ever. I've never even done deep analysis on them. I understand the basic principle and the advantages and flaws, but to me, if we're not running nodes, none of that stuff matters anyway. So let's get a node that works, right? And let's make sure. So I want to get back to your point on substitutions, which is essentially what it is, right? So there may be some chains that are lower volume, like Bitcoin, or higher volume, like Litecoin, which are basically, the difference between Litecoin and Bitcoin in libbitcoin's implementation is 3 lines of code plus a script library, which script hashing library.
So you can write libbitcoin, or you could do Litecoin basically. With
Litecoin,
3 lines.
You don't even have you don't even have to recompile. It's the same code.
Okay.
You just change the config file.
I don't know if you would be able to use MWeb with it, though. I think you would.
Well, I haven't. Yeah, we haven't changed the implementation for probably 6-7 years. But it was one of the Litecoin people that I don't remember who it was. It just came to us and said, "Hey, we want to maintain a fork." I'm like, "Maintain a fork? What do you got? Like three lines of code difference?" And that's what it was. It was like, fixed to the time warp bug, there was another similar Bitcoin, kind of timing bug, and then there was the script. And I'm like, we already have script. Somebody implemented script for wallet stuff. So later I went and rewrote it and optimized it, along with all of our other hashing algorithms. But we maintain that for other reasons. So it was really just, okay, we tack these 3 conditions in the code. Let's make it runtime. Let's generalize our configurations so that we can add these as just forks, right? So not only do we support BTC, we support BTC testnet 3, not the new one, and regtest. And we also support Litecoin, as it existed back then. It should still run as long as you've been soft forking, and Litecoin testnet 3. And Litecoin regtest. So we actually have 6 chains that we can run in the implementation that I've been working on for the last 7 years or so. the idea was that if anything is a Bitcoin, in other words, it follows these basic principles and has these basic rules, any minor deviation from it could be absorbed into the code base and run on the same binary, right? So you could have one binary that fires up multiple processes through configuration differences and support these different scenarios. That's consistent with my thoughts on substitution, is that eventually, not eventually, the way Bitcoin has scaled from the very beginning has been through substitution. When it gets too expensive on one chain, people move to another chain, or they move to another money, and we probably prefer them to move to another chain instead of moving to state money, but they'll do both if we don't provide that option.
I mean, that's what we see happening, right? When Bitcoin fees are too high, Litecoin transactions increase. It's a lockstep type of situation.
Well,
so
stable coins have exploded around the world.
What coins?
Well, that too, stable coins.
Yeah. I mean, I don't give two shits about stable coins, but
well, I get it. I'm just saying that's what people are choosing to do, though, right?
But yeah, I mean, the same thing can be said of state money, right? People just like, I'm not using Bitcoin for this; it's too expensive. I'm not going to buy my beer and pay, back when it was $20 fees. I'm not going to pay a $20 fee for a $2 beer.
Yeah.
So stable coins, aren't Bitcoin, and I'm not really interested in the security model that they have, which is kind of non-existent. So,
right. I've always felt like the obscurity part of things, the best thing you can do to, I guess, introduce a better money to the world. So let's say, by using Bitcoin, by using Litecoin, you're kind of subverting the state a bit. You're trying to say, I want to opt out of this money that I see as a bad form of money versus something that's stable in supply and censorship resistant, all that stuff. And using it, the more people that use it, the more, I guess, it becomes a mass movement and it becomes more difficult to police. And I'm talking like not the technical level, but I'm talking like in the populism level, right? And I don't buy
that. I don't. Popularity has been a defense against the state. Everything the state bans is popular. Everything.
Yeah, drugs.
Sex and drugs and rock and roll, right? Books.
Well, like at some point, marijuana was illegal for a long time, and it's now becoming legal because the populace changed their mindset on it, and they started to say, this isn't an evil thing.
Just the fact that it's been illegal for a long time makes it clear that beer was illegal in the United States, right? The point is that the state can and will ban things that are popular if it serves its interest. The state interest in marijuana and legalization, right? Nobody's threatening the state with weed. They're actually making more tax money in these states by having it, right? So the opposite is true with a coin that competes with a primary tax.
Yeah, look, I get it. I mean, it's a huge threat to governments. That's why I think it's silly to say that they're ever going to that a government will be interested in introducing it. But I think it gets difficult to enforce rules that the masses see as unfair.
Well, no, I don't think so. Masses see lots of things as unfair. I mean, the mass of Venezuelans probably see like their whole regime is unfair, and they still do it, right?
It might prevent.
Probably aren't so happy with where they're living. It's not very. The government's not very popular, right? So
right.
It's
here
we do have
a democracy,
popular things because they're popular. Because the popular things is where the money comes from, right? Banning things is where you get revenue. That's how you can extract tax from them. So the fact that marijuana is illegal allows you to make it sort of legal and tax the crap out of it, right?
See, my thought was always like you're saying, like with running nodes, making it easier to run your own node. If you have 10 million nodes in the United States versus 1,000, that's going to change the landscape of enforcement, right?
It may make people more knowledgeable, may make people more popular, may make it people less scared of it, but it doesn't control the state. The state does the state banned gold. Everybody used gold for money. The state banned it, right?
Yeah.
So when did they stop banning it? When electronic money became predominant. They said, "Oh,
but it didn't go away." It doesn't mean, but gold didn't go away.
Right. It became illegal. So people had to do it illegally. And that's my point, right? Popularity will not stop it from being controlled by the state. You can call it a ban. Like I think somebody started bitching about, I don't know, Italy, 40% capital gain or 65% capital gain. And they're like, this is basically a ban. I'm like, well, no shit. They're not just going to say you can't do it. They're just going to say it's 100% tax, or, effectively they take away the value proposition. If they can take away the value proposition, that's sufficient. So, popularity is not going to prevent it from, the internet was popular. Remember, we didn't have sales tax in the US when we bought stuff on the internet. Well, that popularity of not having sales tax didn't last, right? We pay sales tax.
Like, look at it this way. Like, if I have somebody who works on my house and they go, hey, could you pay me in cash? Like, I know what's going on, right? So
that's something
that the general public, if that guy got prosecuted for tax evasion and he's on trial, I think, I don't know.
Okay,
granted, people probably wouldn't convict him, but I'm just saying, like, the general public might go, yeah, I mean, I get it. It's kind of,
look, what you're doing is you're making the political argument. You're saying that politics, people, elections, courts, etc., the status quo can protect this money. That's the status quo. Politics is what protected the US dollar. People can vote for not having high inflation. They can vote for not being taxed to their money. They can vote for not having all of their transactions monitored. They don't. They vote the opposite direction. They vote for these controls. So Bitcoin provides people, and gold provided people, a way out of that if they didn't want to comply, right? But they have to take the risk. Making the political argument as if it's going to do for Bitcoin what it didn't do for any other money, you can do it.
And I've always felt like the biggest threat to Bitcoin is that the U.S. actually manages their money properly. Right, that the dollar actually has responsible management, which is
success, right? If the U.S. manages money properly, then we don't need Bitcoin.
Right, that's what I mean. Right, so it's financial.
You look at Operation Choke Point, right, and like how the government bailed out a bunch of banks, and yet with Silvergate, they just seized it and they took over that bank, and that was the only bank that was dominantly.
Just look at Operation Choke Point in isolation, right? Why wasn't there outrage? Or look at civil asset forfeiture, seizures, right? Where's the outrage? People vote for this stuff. They keep doing it. They keep, it's okay, because they said they were terrorists or they said they were bad guys, right? And so we choked out all these legitimate businesses with, I think it was Obama's Operation Choke Point, which then has been continued. And, you can't make the argument that popularity is protecting these people. It's not. It's actually what's causing the harm in the first place. Is it, it's popular to get, it gets votes. So Bitcoin provides an alternative, which is kind of what you're describing, a black market, right, where people don't comply.
Right.
People don't, not everybody, a minority, a smaller group of people who are willing to take the risk, who don't want to comply, maybe because they're getting bombs dropped on their heads, or getting shot by their government. That's why they decide not to comply. But in the West, the reasons for non-compliance aren't as strong and the risks are greater. The risk-reward formula is different, and that may change. But, Bitcoin is not a democracy money, right? It's really an anarchy money where if you want to opt out of the majority rule, we're gonna back page you, right? Then you can. But you'd have to take the risk. And it's just like in the old days before legal weed. By the way, in New Hampshire, we still don't have legal weed, right? So, you take your risk. You go buy some weed, maybe people look the other way. And,
maybe New Hampshire not have it? Of all places, I would think New Hampshire
would be the first one. It's a free state. That's what I mean. People, you can't trust politics, right? I mean, we don't have an income tax. We don't have a capital gains. A capital gains tax is zero. Yeah, we have interest and dividends tax that's being zeroed out by the end of next year or this year. And then, we have no broad-based sales tax, but you can't buy weed. You got to go to Maine or Massachusetts, and you can't sell alcohol. You got to go to a state liquor store because they got to make their money somehow. I probably don't want the weed because they'll lose all the alcohol revenues, honestly.
We talked.
So you can buy beer. You can buy beer, but not liquor or wine. So Bitcoin exists, for those people who are willing to not comply. And so, I mean, I'm not saying that volume doesn't matter, but I'm suggesting that white market volume that people imagine is not important to Bitcoin. It's actually harmful to Bitcoin because it kind of shifts the power in terms of mining and transacting into centralized big market players like Coinbase or, you name anybody that's accepting a high volume of transactions is a very powerful economic node. So say Amazon just took Bitcoin, everybody used Bitcoin on Amazon. If Amazon wanted to make a consensus rule change and got together with Coinbase to impose their soft fork, they just do it, right? And other people could continue to run their rules the way they want, but what they've learned is that that their chain didn't include all these other people, didn't include all this centralization, all this white market, because the white market is completely under the control of the state. State steps in and says, all of you miners, all of you merchants are accepting this this fork. They all do it. Nothing they can do about it. Nothing they can do, right? Mm-hmm. So everybody in the white market inherently complies, and that means it has no security model, and it's not worth it. Now people say, well, people won't comply. I'm like, well, yeah, that's the point. Those people are the security model. But why work on this white market stuff, which you just said is not securable? You have to actually not comply to do that, and none of these people can not comply. So I work towards helping people run a node, which means they're actually able to verify their money and secure their money when they're at a small enough level that they can hide. Because the only defense against the state when you're black market is hiding. Right? There's not many places in the world where the black market goes directly up against the state and wins, because when they do that, they are the state. That's southern Italy, I guess. Where Mussolini,
and I think, and this is a maybe a larger conversation that I kind of want to I want to maybe put a pin on this for maybe another day. Is the concept of, and what I've always felt like is, if people don't understand the idea of what it is that makes Bitcoin valuable, right? What you're saying, then that's the thing that needs to propagate, I guess, is the understanding of why am I running a node, right? And I'm never going to run a node if it's horribly burdensome. So if I suddenly,
you're not using Bitcoin. I mean, ultimately, that's what that means.
What's that?
If you're never going to run a node, you're never going to use Bitcoin.
Right. So the more people that actually run their nodes, they use it, they understand the value of it. When those bans come, they're going to be more likely like, okay, but why? Like, I'm not a bad guy. I haven't done anything wrong, right? Like, that's what I think that's like,
what those gold people
civil asset forfeiture. How that's a thing that, of course, it doesn't get talked about by politicians because they don't want to talk about it. We want to talk about these impossible solutions. Like we talk about abortion. Oh, let's talk about that endlessly. Let's not talk about the things that actually are causing, people to be killed by the police. What's causing interactions, causing friction? Like that would be ridiculous. But eventually those conversations have to be had, right? But let's put a pin in this to maybe another day. Animal, did you have some questions too before we move on from nodes? Because I feel like I took over a bit. Or did we cover everything?
I mean, yeah, I covered most of the questions I had. I just want to know what your thoughts are on merge mining and whether or not this increases Litecoin's security and its potential. Because I'm thinking if the government does decide, because of MWeb and its ability to enable some level of privacy, the government might try to target Litecoin. And in doing so, banning it, for example, it might affect the security, right? I'm just, in your opinion, do you think the fact that's merged mine with Doge and now Bell's coin, do you think it's more likely to survive a government ban? Because it's still going to have the hash rate, right? Miners, I'm assuming that miners, S-crypt miners, won't be banned from mining Dogecoin and Bell's coin.
So people, setting aside the increased hash rate from say merge mining, right? Just think about the premise of would it be more secure against, say, the state if it had higher hash rate, right? So there's a subtlety which is critical, right? And it's not subtle. It's actually, but people would see it as like, oh, this is just kind of a very fine point. But what type of security does hash rate give you? In other words, if you have like one coin, it's BTC, and then you have another one that's BTC Prime, which has got like this basically the same, except Prime has 1/10 of the hash rate of BTC. Then what's creating or what is being secured more securely by that, order of magnitude higher hash rate? Is it censorship resistance, which is what we're talking about when we talk about the state? In other words, censorship means control, right? So is it control resistance, or is it something else? And it's actually something else. People conflate those two, and that's a significant problem. Bitcoin has you can think of it as having a couple different security models. One is, as an individual, I got my private keys. Don't lose my private keys. That's a big part of the security model, right? Now, if it's not possible to secure your private keys, that's not an individual problem. That's a system-wide problem, right? But if you do a bad job, it doesn't affect the system. Somebody else just owns your money and they do a better job, right? Bitcoin works just fine if somebody loses their keys, but if nobody can secure them, it doesn't. That's what I mean by individual security, right? If I can operate privately, if I can hide, if I can maintain my keys, all those things are individual. If nobody can do it, it's system-wide. But then you've got okay, what if it's easy to reorg, say, the top 10 blocks, if it's not too expensive because hash rate's low. So in other words, if I do a transaction and I say, I buy a car from somebody with my BTC Prime, and I get the car, it's maybe worth 100 grand. I get and I pay them in the coin, and it gets 9 confirmations, but then and I walk off with the car, and all of a sudden I reorg it out with my miner friends, and I get my Bitcoin back or my BTC Prime back. So what kind of security is that? Is that individual security, or is that system level security, right? Well, it's system level security, right? But you just, obviously you have to wait till your transaction is quite a bit deeper, right? So that the reward that you're going to get by stealing those goods is going to be dwarfed by the cost of producing the chain that's going to get reorganized.
All the hash rate, yeah.
All right. So so that is what's being protected against is attacks. When we use the word term like a Finney attack or a majority hash power attack, which we call a 51% attack. So everything between a one block attack like Finney attack and a perpetual 51% attack is this range of attacks. There's other names for the kind of intermediate ones, but these attacks all have to do with stealing somebody's goods by getting the money coin back also, right? Censorship is not about that. Right, censorship is preventing you from using the money or changing the rules, right, altogether. It's not about getting your stuff. So the hash rate, right, determines the depth at which you have to secure your trade on an individual basis, right? So with Litecoin, for example, let's say it has 4 times the block rate, but it has 1/4 the hash power going into each block. The cost is the same per 10 minutes, right? So why would Satoshi have not chosen the Litecoin block rate versus the Bitcoin block rate? Do you know what there's a known answer to this, right?
From my understanding, it's that the transactions can sync around the world. There's no concern about 2 chains forming.
Okay, you have the gist of it. It's not about transactions, technically it is about multiple chains forming. It's about latency and block propagation latency, and some experimentation showed that, I'm not a historian, but this is how I understand it,
right?
That the higher the latency that you have inherently in Bitcoin mining and distribution of the blocks, the more orphans you're going to see. In other words, orphan is a misnomer, right? All valid blocks have parents. What it means is a weaker chain. So you 2 miners mine a block at the same time, they get produced, right? One of those chains is going to be orphaned, right? It's not going to be orphaned, it's going to be weaker, right? And the one's going to be stronger. And so you can have you get a lot more of these, what we call orphans, if you shrink the period of block production, right?
Yeah.
So the ratio of kind of propagation time to block period kind of determines your level of orphaning.
But so those goalposts move with Moore's law, right?
No, not really, because there's a little bit of yes, but it's really no. The limit is the theoretical limit, right? So information can only move at a certain speed. Like blocks moving around the world, right, move at the speed of electricity, maybe half light speed, right? I think that's been measured in Bitcoin blocks. Blocks propagate like a second or 2 around the world. So you can't go any faster than that. So it's the distance which really physically limits that. And as long as miners are evenly spread around the world, which is the ideal, then you can't reduce that time. You can reduce the processing time, but let's say the blocks are probably the same size forever, right? The processing time gets faster and faster and faster. So there's a little bit of yes to that, because the time to validate the block gets faster. Compact blocks, optimizes, but introduces some complexity because miners can mine unseen transactions, and so it goes back. It gets even worse. So Moore's law, given a constant, kind of transaction block size limit, can make a modest improvement in the time it takes to validate, which is part of that latency, and it can have some impact on the time it takes to propagate. But kind of there's a bound there in terms of light speed, right? We can't go any faster.
Yeah, maybe quantum entanglement one day. We'll see.
But we're not going to, it can't be solved with Moore's law, right? There's always going to be latency. Maybe if everything moved, 10 times faster, we could have a smaller block window. Yeah, that I wouldn't argue with that. But the point is, it's arbitrary to start with, right? Satoshi looked at some different options and said, well, we're getting too many block, orphans in this, maybe 1 minute window. So move to 10-minute window. And if we go longer than that, then people have to wait too long for their transactions to confirm. So we just kind of picked 10 minutes. But the point is, I like the idea, you can have an alternate chain where you have, say maybe maybe a tenth of the hash rate, but you have 10 times more frequent blocks. And so if you waited the same amount of time, you got the same amount of security, right? Theoretically, that holds. If it took you the same cost to produce, 10 blocks as it costs you to produce 1 block, then you're at the same level of depth essentially. But what's nice about having a shorter window is you have that granularity, so you can get 1 confirmation, which is a tenth the size of 10, but it's infinitely larger than 0, right? So 0 conf doesn't work, and 1 week conf is actually pretty good if you're buying things that are cheap. So in other words, it's relative to what you're trying to secure. And if you're buying your coffee, Litecoin's overkill, right? 1 confirmation on Litecoin is overkill. So to the extent that you're not flooding the network with orphans and causing this to be, itself be a problem in terms of, because orphaning, it's not just a data problem. It's a question of when you can get confirmation, right? If you get a lot of orphans, you can't use that first block. It's not very reliable. You have to go like 10 down and kind of defeat the purpose, right? So there's kind of a limit there. But having different chains with different levels of different block periods, implies that you can make the trade-off between one and the other based on the amount of money you're trying to secure. So example, cash in my leather wallet versus cash in my home safe or my drawer, right? Versus cash in maybe a big vault versus, cash in Fort Knox. I don't know, right? So there's this continuum that people do use, right? Between their banks and their home and their wallets and their, change in their car when it comes to the lower risk that they're taking, lower value transactions, right? Like some people around here, they just leave, stacks of cordwood and eggs and stuff on the side of the road, and people voluntarily pay. It's low risk. It's okay to make those compromises based on trust and risk, but and with different chains of basically the same consensus rules, you can accomplish that up to the physical limits where you start getting excessive reorganization and stuff. So I wouldn't, it seems perfectly reasonable there be a chain that we get 1 block an hour, 1 block a day, and have a huge hash rate, and it's securing everybody's personal yachts, and that's it, right?
Is it the hash rate? Because my thought has always been it's not necessarily the hash rate, it's the amount of capital needed to being deployed.
It's the cash cost that matters, right?
Hash cost, right?
Yeah, hash rate and hash cost are, we use the terms interchangeably because presumably, if you presume all miners are equally efficient, they all have similar, same energy cost, and it's the same cost of producing the same blocks. It's not, obviously, but it's an average. So hash rate roughly correlates. So basically what it amounts to is you're not going to mine a block unless you make a profit. Competition is going to bring that profit down to the minimum level, which means it's going to be around the historical return on capital, which is going to be around 10% on average. So the return
the irony is that people don't buy hash rate with Bitcoin.
Well,
so It's
I mean,
it's
that's
been
not
gamed a bit, right?
maybe ironic, but not critical. But what I'm describing is, the cost is going to be the reward. The block reward that you see, right, for the Bitcoin value of the block reward plus, that has to include your return on investment, which has to reach at least 10%, or people are going to drop off the network. If it
Right.
drops below 10%, it'll drop off, and people, if it drops above, competition comes in. We'll keep it around, some return on capital, which is based on time preference. So that's fairly regular. You can see that in the data. But what it implies is that the hash rate will equal the cost of hashing at the block reward level. So if the block reward's $1 million, the cost of hashing a block is $1 million, inclusive of that cost of capital, right? They made their profit, but that there was a cost to that capital. They have to pay it back. They pay back their investors. So, okay, you got $1 million blocks, you got $1 million hashing going in to produce those blocks. If hashing is equally efficient under that assumption, you get twice the hashing, you get twice the cost of producing the block. So when you trade something and somebody wants to produce a what's going to be a reorged block to do a Finney attack on you, they're wasting $1 million to get what you traded, which means that they got to be making more than $1 million, and they've got risk that they didn't win that block. So
so are you is the concern, do you feel like the market cap is really significant in this, or are you more thinking just in the physical world of trading goods for the Bitcoin
market
but
capitalization
like as the market as a whole? Does it?
You mean the current trade, the last trade price multiplied times the number of coins in potentially in existence is an important figure? No.
Well, when talking about security,
what matters
is
security.
Like if I can find a way to, short the market and profit because the cost of hash is infinitely small versus the potential reward of gaming the market by stopping block propagation for 2 hours or
if you
6
can
hours or something, right?
If you can predict the future price of anything, you can make an unlimited fortune. So I don't make those.
But they can influence it. Can miners influence it is the question, I think.
No, they're not anymore. Miners are just buying Bitcoin. They're just buying it for electricity.
Right.
They're no different than anybody else, buying. When I say buying, I mean you're trading something for some coin. So if I sell my car, I'm buying Bitcoin. I'm buying it for a car. If I'm mining, I'm buying Bitcoin. I'm buying it for my electricity.
But if mining is so much less expensive, it becomes incredibly less expensive to acquire it via mining because the government's subsidizing my electricity.
Well, that's not less expensive. It's just being paid by somebody else. It's still the same cost, right? Yes, if the taxpayers pay some of your electricity costs, the cost of mining is still the cost, right? And governments could come in and mine at 51% and pay that cost and force a perpetual majority hash power censorship regime on people. And other miners are going to have to take the transactions they're censoring, which presumably would have higher fees and mine at a higher cost than that. But it's not like it's free. The cost of mining is a real cost. That's what makes it a useful function of Bitcoin. So if a state wants to do that, they're going to lose real money by not taking the real fees and having to subsidize their hash rate to prevent themselves from losing their majority. So everybody that's getting Bitcoin is paying for it in one way or another, and they're paying the market price for it. And they may be guessing at future prices. Price can obviously fluctuate, but the theory is pretty straightforward economically, that everybody's paying the price for it, whether it's new coin or old coin, doesn't make any difference. And the production of new coin is not inflationary on old coin because it's produced at a market price. There's my innovation for economic theory. Nobody fucking figured that out. Right?
Well, but I think where I'm gonna press you a little bit. What I mean is that because mining is subsidized and generally, like you said, the government can produce electricity and force essentially free production of Bitcoin. They aren't paying the market price. They're paying nothing to acquire.
No, they are. Somebody's paying for the electricity. I guarantee you.
No, taxpayers, right?
Right.
Yeah.
Right.
Well, what I find interesting is like Bitcoin miners and Bitcoin Cash miners are essentially they're mining at the same cost, right? Like they're getting the same out of it per watt in terms of US dollar value.
Yeah, because
Whereas,
all capital invested is going to return the same rate. Otherwise, it won't do it. So if
I
they're
mean, I
mining,
find that really surprising though. I would have assumed that Bitcoin Cash would be less profitable, right?
no mining is going to be less profitable or more profitable in the long run, right? In the long run, which is the run that never happens. But in other words, everything is always seeking. All business seeks a return on capital. People who start a business, they want infinite return on capital, and people who buy from that business want to pay zero price for their products. But what actually happens, everybody pays the same price for capital, and and it doesn't matter if you're rich or poor, you'll pay the same price when you go to the store to buy a given good, typically. Unless you go to France.
I mean, that's assuming that like Bitcoin Cash survives and the chain doesn't stop, right? Like, because at that point, then all that capital will be lost.
If somebody's running a business, they have to make a profit. If they're not making a profit, they just shut it down. If they're making more profit than everybody else shuts down their businesses and moves into competition, reducing the profit to the point where people start quitting again. So there's this constant tension between, where people are trying to maximize their return on capital. Doesn't matter what the business is. Doesn't mean if it's Bitcoin Cash, some other shitcoin, Bitcoin, selling eggs on the side of the street. It doesn't matter. People are going to maximize their returns. And that might not be all, kind of fiscal returns. It could be psychic returns, right? I like working at home, so I take less. But the return is always, the market is always seeking the same return across all business. And we used to call that the interest rate. That's what the interest rate is, the interest rate, the one and only, right? With arbitrage around the world, it seeks a single value. And that value is historically typically around 10%. And I've been an index investor for over like 24 years now, since 2000. And I still average around 10% on a total, market index. So that, and that's, I don't know. I don't need to go to it, but there's a reason for that. And Bitcoin Cash miners are not going to mine if they're making 5%. They're going to index. And if they're making 20%, competition's going to come in and reduce their margin down to 10% or 5%, and then they're going to start quitting, and they'll go back up to 10%, right? Because mining's a zero-sum game. The more hash power that's introduced, the lower your probability is going to be, and so you're going to start losing money unless you're the most efficient. So it doesn't matter what you're mining. In theory, the mining return is going to be the same.
Even if you're mining S-crypt, right? You're mining 3 chains. Apparently, with an L9, which is the latest S-crypt miner, you can make something like $25. $25.
What your coin is, what your business is, what the technology is. Mining is always going to end up being, or the return on capital.
It'll trend to the same rate. He's saying that you may have these short instances,
right. So
because there is inflation in these chains, and there's a friction to acquiring capital and access to electricity that may allow for higher profits in the short term.
Right. Prices vary, right? And they're not predictable. As a consequence, there's a lot of fluctuation, just regular fluctuation in your returns, right? Over time, those get averaged out. But then there's also what we call entrepreneurial reward. So there's business reward, which basically seeks to return the cost of capital. So if I lend money, I get my 10%. If I start a business, my profit on the business, above what I invested is 10%. It's the same question, right? But if I'm an entrepreneur and I develop something that nobody's seen before, it doesn't exist anywhere in the world, I have this window in time where I can charge what anybody will pay, right? Because there's no competition. So the holy grail for your entrepreneur is that. So in economics, that is what we call profit, right? Not return on capital, right? Like a market return on capital, interest is not profit. Profit is what's above that. And so entrepreneurs are the people seeking profit, excess return. But in order to get that, they're taking higher risk, right? So even then, they eventually average across all of them, end up with just return on capital. But for example, you have like a Microsoft or a Google, which skyrockets, right? Because they don't have competition for a time. And then over time, eventually all these, this used to be IBM was the most profitable business in the world. Now it's like Apple. But the old ones of the old days, they've come down to, standard returns, GM, the big ones with the high returns of the old days. So all businesses are going to seek that. And that's a consequence of competition. And the only thing that really prevents that is when you don't have a free market, right? So you can have like a telecom in Mexico where the guy becomes like one of the richest people in the world because there's no competition. So that's what guns do, right? They allow you to steal people's money. But short of not having a free market, all miners are going to seek this, that reward is going to seek the same value. And it happens very quickly because it doesn't require any kind of bigger ones become more profitable. So being, centralization has an advantage, but any number of mines can just pop up anywhere in the world. They seek the cheapest electricity, the lowest capital costs, and they're gonna be profitable. So,
all right, I got it's Why Litecoin. He was the original co-host of this pre-animal. He had a list of questions. I'm going to do this rapid fire. So if some of them are long answers, maybe we just.
All right, we'll try to go quick. I'm going to probably have to drop off, and we're going to approach in 2 hours. We're going to have to drop off by noon.
Yeah, that's fine. That's fine. And we'll save our patent conversation for another day. But all right, so do your recent 1 hour node sync change your thoughts on Bitcoin scaling?
No, the reason it's sinking in under an hour is because I've always had the understanding that it could. So my thoughts on scaling it's not about scaling transaction rate. It's about the ability for everybody to run a node.
I feel like we answer a lot of these. Besides the increased cost of validation with increased block sizes, are there any non-technical or economic constraints when increasing block size? I don't know. That's not a good question.
I mean, you have more capacity. Your fee per transaction is going to be lower, but you're going to have more of them, presumably, right? The central issue is just the cost of running a node.
Okay. Is there a way for you to tell how many people are using libbitcoin?
No.
Easy questions. These are good yes or no questions. Do you ever worry about personal ramifications? We're talking about black markets in an era where government is becoming more restrictive on speech.
It crosses my mind. I don't worry about it too much. I've always been kind of fairly careful about what I do. I don't tell people what to do. I tell people how things work. And I did self-censor a bit when I went to Beijing and gave a talk to a meetup group. Basically, their recommendation was, say whatever you want, just use the United States as an example instead of China. And so, yeah, that was it. And no problems.
And this is probably a good one that might be a good way to end it. What do you think about kind of what's been going on with the leveraging with MicroStrategy, Michael Saylor, the instrument that Bitcoin has become in the last 5 years in particular?
Yeah. So I'm not a speculator. I don't really care about that stuff. Some of the stuff he says is kind of obscene, but just to your specific question about what's the strategy there, it's pretty straightforward, right? Like I've had this experience. I was an entrepreneur. I retired basically before I started working on Bitcoin. And I sold a couple companies, and I was, on the board, some bigger companies, and I, you can see a decent sized company, even a private company, can borrow money essentially from the central bank, right? They're bankers who then borrow it from the central bank ultimately at a steeply discounted rate versus what a consumer or small business could do. As a small businessman, it was extremely difficult to get a small business loan. The only type of loan you can get as a small business is tied to your personal credit. So it's basically a personal loan, right? And those are government subsidized, but they're nothing like what you can get as a large company. So MicroStrategy, public company, can go to their bank and borrow money from the taxpayer at almost no interest. So I don't know what the current rates are, but so at one point I had this experience where company that shall remain nameless decided to borrow, I don't know, it was like $20 million and just issue the money as dividends to its shareholders and then pay it back over time. Why not, right? Well, okay, if you're earning 10%, again, I go back to my previous discussion on returns, right? If you're earning 10% on your money and you can borrow at 1%, you're getting 9% for free. 9% on $20 million for how many years? I don't know, right? That's a lot of money. So if I can take that money and pocket it and invest it over the time that it's being paid back, at 10%, then I'll make real money. So that's how the game works. Any kind of corporate finance guy is going to borrow what he can from the feds and from his bank, right? And pay it back over time. And if you have the ability to return more than you're borrowing for, which you should have to do if you're a moderately successful business, right? You're in business, then you're going to make a profit. So big banks, JP Morgan, those guys that buy bonds at the open, the open market bonds, government bond sales, treasury sales, they borrow money from the Federal Reserve directly, and then they use it to buy the bonds. And if the Fed wants, to change interest rates, which is kind of measured by the rates on these bonds, they just change the amount of money that they're giving away for free to these banks so that the banks will be more or less inclined to buy the bonds and therefore affect the bond prices, right? So it works the opposite of what people think. They don't set the bond prices. They print more or less money. So getting access to the money printer is the key. MicroStrategy, obviously, like any other company, knows that they have access to the money printer, and they're willing to take the bet that other companies aren't willing to take, right? That Bitcoin only goes up. So if it only goes up, and if it goes up faster than the rate of interest on the money, it's an easy profit, right? Just like buying T-bills at the auction and flipping them, immediately.
There's basically infinite demand for cheap money.
There's infinite demand for any money.
Yeah.
Right? Rothbard
low interest money.
The demand for money is always infinite, right? It's not people always want it. And you can always operate under that assumption because it can acquire anything else. And it has no cost to hold. The carry cost is dwarfed by the fact that it's free. So so you got as much as you can get, right, from the taxpayer, tempered by the fact that, if Bitcoin doesn't go up long enough or strong enough, then you will fail, right? So people are just doing the math on MicroStrategy to figure out, okay, what does Bitcoin have to maintain in order for him to not fail based on all these loans he's taken out against the company? But it's a pretty simple thing, and basically, people have argued that he's kind of running the system against itself, right? Like if everybody did this, if everybody just borrowed money from the printing press and the printer went burr to lend them this money, and then they bought Bitcoin with it, and Bitcoin went up. Of course, there's inflation making Bitcoin go up, but if Bitcoin only went up at the rate of inflation, then it's not actually going up in terms of purchasing power, right? If it only goes up at the rate of inflation, what's happening is that if people that hold dollars are being taxed and people that hold Bitcoin are staying the same. That's what would be happening if it's only going up at the rate of the printing, which is kind of like this theory. So it's a transfer from people holding dollars, not from the state, right? It's a transfer from people who have savings in dollars or dollar-denominated securities to people holding Bitcoin if the printing is making the Bitcoin go up. And that's the theory, right? What the theory is, if everybody's losing their savings, then the dollar will collapse, and it'll all be in Bitcoin, right? The theory doesn't really seem to understand that the state controls MicroStrategy and everybody else that's in the white market, and can seize their Bitcoin just like it seized the gold. So it's kind of a tenuous strategy, and it's also based on the assumption that Bitcoin always goes up, at least at the rate of inflation, right? Or at least at the rate of the interest on the loans. And they're pretty low, but Bitcoin has no yield. It doesn't earn, it doesn't produce anything. It has no reason to go up except for speculation and monetization, right? So if we don't keep monetizing Bitcoin, don't keep making it go up, that bet loses. And there's nothing inherently that says it will go up. That's a gamble. It's not something you can see in the history of the return on the stock market, for example, which is the markets have to return at a positive rate over time, or everybody dies. Everybody starves to death. There is nothing, because we consume everything that existed and nothing more is getting produced. So markets go up for a reason, and that's yield or the interest rate. Objects do not. Houses don't, gold doesn't, rocks don't, right? Bitcoin doesn't. So it's a speculation, and that's the risk in his strategy, that he's speculating on growth, when there's nothing driving the growth that is provable. It's based on what humans are willing to pay tomorrow, and that's not predictable.
How good are your sales strategy? Yeah, the thing that I didn't realize is how many old holders there still are. Like 10 million coins are still held by people that maybe mined it was like pre 2013 or something like that. And
it's hard to say how much of it is lost,
Yeah, true. And I think that's an unknowable thing. And for him to kind of put everything in, all his eggs in one basket, when he doesn't have that pretty critical piece of information, because you're talking about somebody today having to lay out $70,000 versus somebody selling off one coin at a time that may have 20,000 coins. You don't know who these people are, right? So it's definitely a risk, and it, if it fails, it will fail spectacularly. Because it's going to unwind at some point. Or he can maybe always just keep borrowing and keep propping it up. I don't know.
Yeah,
if it was a good strategy, he wouldn't have to keep buying.
It's a very simple formula, right? It's just he doesn't have really a business. He's just an arbitrage machine.
Yeah.
And I think he's kind of started out as a way to kind of I think if you look at the stock market history of before he started buying Bitcoin and MicroStrategy, it was flat for like 20 years.
Yeah.
Right. In a time period when you have 10% like average annual growth, especially for tech companies, right? So that's a horrific loss. And it's worse than Europe. Europe has at least grown 10% over 20 years. The US grows at, market returns are like 9.5%, 10% each year for the last 20 years. So Europe is becoming a third world country, and MicroStrategy was underperforming that, before it started doing this. So to me, that's just for me taking a look at the stock charts, right? I don't know what their dividend distributions were, but that would be, I think that's a total internal rate of return on the stock, which would be a fair, explanation. So I think it looked like it was just a way to, save a failing company and take a huge risk. So it's a gamble, right? Put it all on red and it's paying off. But it could, all that has to happen is those notes go underwater. And where's the money come from?
More borrowing, or
sell the coin and then more borrowing. Maybe rates go up, Bitcoin goes down, it's over. Right?
Yeah.
Rates have gone up quite a bit. So, I'm not sure.
Well, now he's borrowing for free from his shareholders. He's selling shares because for some reason there's a premium, right? Yeah.
That's also, we call that a pyramid scheme. As long as you have some new person to come in, to give you money for free, you can keep it going. And I'm not saying that, the system, it's not running as a pyramid scheme, but if that was the answer to a Bitcoin going down and interest rates going up, well, as long as we keep money coming in, we can keep paying off these loans. Maybe, but you got to pay back that new money at some point. So when do you do that? Right, Bitcoin got to go up. So it's a gamble on it going up, which is why he's pumping, right? And it's also a gamble on interest rates, kind of going up slower or not being as high as Bitcoin. And it's it's a big math problem, and there's a big asterisk next to interest rates and Bitcoin price appreciation.
Right, things you can't control.
Gamble.
All right, we are almost at 2 hours, and I do appreciate all your time. This was like, seriously, I learned a lot about what I hope to learn about with the node implementations, and I think those things are, definitely obscured. They're difficult to talk about and understand, and so I think what you're working on is awesome. And so, can people contribute in some way to you and libbitcoin? I mean, you take donations. You just want help with.
We don't like to have a donation address. We've had in our history, we've had like 2 large donations. Nothing like the core guys get stuff, and we've had a couple of smaller ones that we just kind of put on a wallet in case we need to make a server or something. But if people really or seriously want to, like we had one individual who wanted to remain anonymous, but he was kind of a high net worth type. He just threw us some change, and that was great. If somebody wants to do that, you can contact me directly. I don't take any money myself, but I redirect it to, like, I've never accepted money for anything, speaking or any even consulting. I just take travel if I'm going to consult for somebody. So I direct it to other people on the team. I even sometimes have funded them myself. And so I act as a conduit for that. If it's smaller amounts, people can contact me and we'll give them an address and we'll throw it on our wallet for a rainy day fund. But we don't have like a Kickstarter, or public address or anything like that.
Right.
So yeah, maybe somebody wanted, now that we're starting to see some results from our V4 work in terms of performance, people have started to take more of an interest and ask those questions. So
yeah, it's very cool what you're doing. So
there's some solid people that work regularly on the Bitcoin. I'd love to get them on full time. And three specific individuals that are listed on our libbitcoin.info website that kind of shows the team. And
okay.
So if somebody really wanted to step up, that would be tremendous because we've been lucky enough to have myself full-time self-funded and another who's worked full-time for about 2 years. That's been up now for a while, so he's kind of doing it himself, but for a couple of years funded and was able to stay with us. That helped a lot to really get things where they are. So love to keep that going and get a couple others on board that have experience and desire to work on it.
All right. Well, hey, sounds good. I appreciate you taking so much time.
Yeah.
So
having me on. It's great.
Yeah, maybe we'll do it again. I mean, I feel like there are other topics.
And now that we support Litecoin, right? So
yeah. I mean, I think maybe there's
awesome,
a Litecoiner out there that wants to.
Got to get the Mimble on, but we don't have that.
Maybe we'll start a bounty. We'll see.
Yeah.
All right. Well, thanks a lot, and everybody. Thanks for viewing. I guess follow, like, subscribe, all that stuff, and go out and get some sunshine, right, Animal?
Yes, sir.
All right.